To verify means to prove the truth, accuracy, or correctness of something. We've explained in the previous video why we need to verify things, and in broader terms how it applies to chip development. In this video we are going to focus on the flow of activities in a real project. Verification is not optional, as I've stated previously, it is roughly 3/4 of the development process. Chips cannot be changed once they are created, so to develop a chip means you have to be sure that its functionality is correct before it is manufactured. Any chip development comes from a requirement. That requirement is based on the final user needs, previous products of the company, marketing, and chip architects. All of this information, combined together with the know-how of designers and verifiers, results in a series of specifications that are vital to the development process. The first documents to be redacted are the requirement specification and design specification. The requirement specification states the goals of the implementation, while the design specification states how those requirements are to be achieved. The requirements are meant to be freezed at an early stage, while the design specification is a live document that gets updated together with the HDL code. A product is composed of hardware, software, and documentation. All these components are developed at the same time. Both design and verification follow the divide et impera principle. Multiple sub-blocks are being designed and integrated vertically to form the final product. The integration stack is as such: module to block to subsystem to SoC to board and finally to system. And each integration layer requires verification, with some minor blocks being verified together. Now that we know the entire flow, from requirement to board, we can go through the steps of pre-silicon verification. The first step is planning. Based on the specification of the product, a V-plan can be created. Q&A session and sit-togethers with the designer are often required to understand the entire functionality of the DUT. The V-plan is supposed to cover the what of the verification. What do we want to accomplish? It should contain all the checkers that are supposed to assess the correctness of the RTL logic, as well as certain metrics that should be collected to assess the completeness of the verification. Tests and scenarios are also part of the V-plan. They are usually generic at lower integration levels, but they can become the entirety of the V-plan from subsystem and upwards. Apart from the V-plan, this is also the stage where the verification specification should be started. This is a live document that will be updated as the test bench is developed. In the initial state, it should cover the architectural details of the verification environment and the tools that are going to be used. The second step is implementation. Based on the V-plan and the verification specification, the test bench can be implemented. It should contain all the resources necessary to generate stimuli and field metrics, as well as validate the correctness of the DUT. We are going to go in a lot of detail in future videos. For the third step, after the test bench has been implemented, even with partial functionality, the debug process starts. As engineers, we are humans. We are going to make mistakes. Bugs can be encountered in the test bench as well as in the RTL. All failures should be analyzed, test bench bugs should be fixed, and the RTL bugs should be described and documented for the designer to fix and the project leadership to track. This process can be done by analyzing logs and waveforms, as well as implementing additional functionality to track and expose the problems that were not foreseen in the planning or implementation phases. The fourth and final step is the coverage closure. We are aiming for all of the test cases to pass and for all of the planned metrics to be achieved. This is a long process at times, and it is dependent on tools and randomization. Also, there are more than one way to track that a feature was exercised. Sometimes the planned metrics are too vast and other times are too narrow. Adjustments, reviews, and exclusions have to be done for both test bench metrics as well as RTL metrics, like code coverage. The final documentation that has to be presented to close verification is called the verification report, and it covers all of the necessary steps that someone has to undertake to replicate the results, as well as a presentation of the results, exclusions, waivers, and limitations. All of the steps presented in this video will be revisited in depth with examples and explanations. So, What have we learned today? We learned about what makes a product and how a development project is started. We learned about the steps necessary to undergo a verification project and all the documentation involved. We have taken the first steps today to understand the effort and the stages needed to build the chip. I am Andrei, we are AMIC Consulting. We provide services for verification in a variety of areas like computing, automotive, servers, telecom, and others. You can visit our website at the link on the screen, and if you are there, you might as well visit our brothers and sisters at AMIC EDA. That's all for now. Thank you for watching.